Hey guys, welcome back for another video of the LeetCode 75 study plan series. Today we are going to be doing our last problem in the Q category. So this problem is called Dota2 Senate. And Dota 2, my understanding is a game. I haven't actually played it myself personally, so don't get mad at me if you're a big Dota fan. But apparently, this problem is based on the game. Uh, so uh, it's quite a meaty problem. There's a lot of instructions, but I'll go ahead and read these just to make it clear for you guys. So in the world of Dota 2, there are two parties, the Radiant and the Dire. The Dota 2 Senate consists of senators coming from two parties. Now, the Senate wants to decide on a change in the Dota 2 game. The voting for this change is a round-based procedure. In each round, each senator can exercise one of the two rights. Ban one senator's right. A senator can make another senator lose um, all his rights in this in all the following rounds, or announce victory. If the senator found the senators who still have rights to vote are all from the same party, he can announce the victory and decide on the change in the game. Given a string Senate representing each senator's party belonging, the character R and D represent the Radiant Party and the Dire Party. Then there are N senators, the size of the given string will be N. The round-based procedure starts from the first senator to the last senator in the given order. This procedure will last until the end of the voting. All the senators who have lost their rights will be skipped during the procedure. Suppose every senator is smart enough and will play the best strategy for his own party, predict which party will announce the victory and change the Dota 2 game. The output should be Radiant or Dire. So for this particular problem, we have to um, use a queue data structure. We'll be using two to represent each party, right? And we have to set up some sort of mechanism that basically imitates the uh, voting procedure for this video game Dota 2. So basically, from my understanding, the way that this works is that if a senator casts a vote, um, they can either cast a vote, or they can cast a vote, but they can also ban another senator's right to vote. So if they don't get banned, then they go to the back of the line to vote again, and that's why we're using a queue, right? Is because if they're in the front of the line, it's their turn to vote. Um, they either vote or they're banned, and if they vote, then they can go to the back of the line again, and we just keep going until the queue is empty, right? So let's go ahead and implement this solution. I think it will make a lot more sense once we have everything written down in our code. So let's go ahead. Like I said, let's set up two queues, one to represent the Radiant Party and one to represent the Dire Party. So in order to do that, we're just going to do queues, and we're going to make these queues integers. And these queues, the integers in the queues are going to represent the places of each senator in line, right? So let's do the Radiant one first, and then to initialize the queue, it's linked list. All right. Okay. Now we have to basically fill our queues with the um, respective parties, right? So we're given our string Senate. So let's do a standard for loop, and this is going to go through the entire Senate length. All right. Okay, so in order to do this, what we're going to do is if Senate char at I is equal to R, then we're going to Radiant add I, which represents the index, right? Else, we're going to add it to Dire because it can only be an R or a D. So, cool. All right. So now we have our two queues, and then each senator in their own respective party, right? Represented by their position in line. So now what we have to do is simulate the voting. So let's set up a while loop while both of these queues are not empty. We want to keep simulating the voting, right? Because basically what happens is we know a party wins when uh, when their queue is not empty and the other queue is empty. So Radiant is empty and Dire is empty. Okay. Now, first, what we want to do is we need to come up with a way where we take both of the senators from each party in front of the line who are going to vote, and then one of them gets to vote and then go to the back of the line. The other one gets banned. So what we're going to do is we're going to poll both of them, and then if that since it's an integer in the queue represented by its place in line, then the value which is less is going to get added to the back of the queue again, and then the other one is just going to disappear, which is going to be basically an implicit representation of them getting banned, right? So in order to poll them, we can do this with just making an integer r radiant.poll, and in the same line we can also do d dire.poll. And remember, poll is kind of like pop with the stack, right? We're just taking the top value, taking it off the top. Okay. Now we want to set up those conditional statements that I mentioned. So if r is less than d, then we're going to add it to the back of the queue again. R plus Senate dot length. Cool. Else dire dot add d plus Senate dot length. Cool. All right. So this will take care of our of simulating the voting, right? And then now we just have to return either Radiant or Dire to represent the party that wins. So we can set up a ternary statement. If you're not familiar with that, I'll show you what it is right now. But basically, set up a ternary statement to determine which string we're going to return, Radiant or Dire. So let's go ahead and set that up right now. So if Radiant.size is greater than Dire.size, question mark, then Radiant, we're going to return Radiant, and if not, then we're going to return Dire. So the syntax on this is pretty straightforward, right? This is our condition. We're trying to figure out which size. So if the Radiant size is bigger, then the left condition, or the left result right here is going to be returned, and if not, it's going to be Dire. All right, so pretty straightforward syntax if you haven't used that before. All right, now let's go ahead and run this. Awesome, as you can see, it passed the first two test cases, so let's go ahead and submit. Awesome. Okay, so we went ahead and we passed all of the test cases, so we know that we have a correct solution. For the time and the space complexity, the time complexity is going to be big O of n. We're just iterating through the input string once, so that's a time complexity of big O of n, and then for the space complexity, it's big O of n as well, because we have two different queues, but each queue is just the size of n. So that means that we just have a space complexity of big O of n. So yeah, that's it for today. I hope that you enjoyed the video. If you did, please go ahead and leave a like to show me, that you support the video, and please subscribe for more related content. And as always, please leave a comment if you have any suggestions or questions, and we will see you in the next video. Thank you.